A3 is you're going to solve systems with many equations and many variables. You have to have the same number of equations as you do variables, or else it's going to be, well, not so fun. Okay, you're going to get things like lots of solutions or no solution, etc. Okay, so we're going to start off with a rather simple one. Okay, here we go. This one has 3 variables, but you're flat out told that z equals 3. All right. So you can substitute rather quickly here, and we're going to do that right now. So we're going to take this equation that already has a variable alone, and we're going to plug that into another equation for that variable. So we're going to practice substitution first. Okay? Plug that in for z here. If you do that, rewrite this second equation as y plus 3 times the z value of 3 equals 6. All right. So negative 3, good, because y plus 9 equals 6, so y equals negative 3. Now I need to find x. So what I'm going to do is I'm going to take the equation that has an x in it, and I'm going to plug the y value and the z value into that equation to solve for x. Okay, so plug z into the top one too. And now go ahead and plug y in at the same time to the top equation. So if I rewrite the top equation, be very careful when you're substituting not to drop any negatives. All right, if I rewrite the top equation, I get 2x minus the y value of negative 3 plus 5 times the z value of positive 3 equals 22. Okay, let's solve for x. 2? Did you say 2? Yeah. 3 over 2. Okay, let's find out. So 2x plus 3 plus 15 equals 22. 3 and 15 add to be 18. So 2x plus 18 equals 22. Subtract 18. 2x equals 4. Divide by 2.
I understand.
X equals 2. Now, let's talk about how, all right, let's talk about how to write that solution. You're going to still write it in an ordered triple this time, and you always put things in alphabetical order. There's one exception that I can think of that. Usually, if time is involved, we put t first. All right, usually. So your solution will be the ordered triple: 2, negative 3, positive 3. You do not have to graph it. I can show you how to graph it, but you do not have to graph it. Okay. So let me go back and rework this problem with you using what's called Gaussian elimination, because when you have an equation that's not so simple, a system of equations that's not quite as simple as this one, it's going to be a little bit more useful to use Gaussian elimination. Okay? It's basically just piped up elimination. You're basically going to use elimination multiple times in the same problem. Okay? Do you want to work through this one, or do you want to work through a different one that's a little more complicated? Maybe we do a little more complicated one. Not terrible, just a little bit more complicated. May I erase this one?
Go ahead.
Okay. The general gist of Gaussian elimination is you're going to take an equation, you're going to want them next to each other. All right? When I was in high school, I just basically rewrote them next to each other. But if you want to actually physically switch them in your system, you can do that. But you're going to put 2 equations next to each other. All right? Then you're going to get opposite numbers in front of one of the kinds of variables. All right? Like opposite numbers in front of x or opposite numbers in front of y. And then you're going to add the equations together so that those variables cancel out. That's the elimination aspect. All right? Here we go. So x plus y plus z equals 6. And 2x minus y plus z equals 3.
Is it an easy one or hard?
It's a medium one. It's more difficult than the last one because it involves all three variables and all three equations. But it is not super difficult. It won't take us super long, okay? If we don't get through it before the end of the class, I'll finish it on the video and you'll be able to see it. We'll continue with it on Monday, okay? 3x plus y minus z equals 2. Okay, here we go. So we're going to take two of these equations. We want them next to each other. This says switch two equations. Basically, you want two equations that you're going to work on eliminating a variable next to each other. So if I look at these two, which two do you want to choose? Bottom two or top two? Both of them will easily eliminate what? The y. You could eliminate x, but the y's will already cancel out. You don't even need to multiply by something. So let's take the top two. We'll do the bottom two in a second. We're going to do it multiple times. Watch this. Here we go. Hey, if I take these top two equations and I add them together, because they already have opposite numbers in front, then I'm going to get, let's see, what as a result? If I add these two equations, 3x plus 2z, because the y's cancel out briefly, equals 9. Okay, don't stop there. Now you need to eliminate that same variable using a different set of two equations. Okay, so let's eliminate y again, but we're going to use a different set of two equations. So we're either going to use, we're not going to use the first and second one. We're either going to use the first and third or the second and third. You guys were voting for a second and third a second ago, so let's use those. I can add those together because they already have opposite numbers in front of y as well. All right, we'll get to talk more on Monday about what to do if you don't have opposite numbers already there. This kind of instructs you, but we'll have examples in class. Okay, so if I add those together, I get 5x equals, wait a minute, no z's. Oh, so it's equal to 5. Now, I have two variables in one equation and one variable in the second one. If I had two variables left in both of these equations, I would do elimination again with what's left. However, at this point, I would probably say to take this equation and find what x equals. So what does x equal? 5x equals 5, so x equals 1. Now I would take that x value and plug it in right here. And if I do that, I'll get z. Let's see, 3 times 1 is 3, plus 2z equals 9. Subtract 3 from both sides, I get 6. So 2z equals 6, z equals 3. Okay, now that you have x and z, you can find y in any of the equations that had x, y, and z in them. All right, you need a y, and they can involve x and z also, since I know what those are. So which equation do you want to use? The top one? Oh, okay. So x plus y plus z equals 6. X plus y plus z equals 6. So 1 plus y is y for right now, plus z is 3 equals 6. So y plus 4 equals 6. Y equals 2. What's my solution? 1, 2, 3. All right. Good work putting those in alphabetical order. All right. Now, what happens if you don't have opposite numbers already? That's when you start multiplying equations by numbers to get opposite values. All right. Again, we'll finish this Monday.